Hi, I'm Dana Gardner, Principal Analyst at Interoper Solutions, and I'll be your moderator for today's panel examining UNIX, a journey of innovation. We're here with a distinguished panel to look at the 20-year history of UNIX and its standardization. So allow me please to introduce our panel. We're here with Andrew Josie. He's the Director of Standards at the Open Group. We're also here with Darren Johnson, Director of Solaris Engineering at Oracle. Tom Matthews, Distinguished Engineer of Power Systems at IBM. And Jeff Kyle, Director of Mission Critical Solutions at Hewlett-Packard Enterprise. Well, to look into this very interesting subject, it's not often that you get a 20-year anniversary in tech where the relevance is still so high and the prominence of the technology is still so wide. So let me first address a question to Andrew Josie at the Open Group. You know, UNIX has evolved. It's been evolving, though, during probably the most dynamic time in business and technology. How is that the case? How is it that UNIX, being so prominent, but a standard that's clung to its roots, compatibility and interoperability, how has that been able to maintain its relevance in such a dynamic world?
Thank you, Dana. Well, as you know, UNIX started in Bell Labs by Thompson and Ritchie back in 1969. A very innovative, very sort of different approach, an approach that has endured over time. And so, we've seen during that time a lot of work has gone on in different standards bodies, and we saw in the early 80s there were the Unix wars, almost different sort of fractured versions, different versions of the operating system, many of them sort of incompatible with each other, and then the standards bodies sort of bringing them together. We saw efforts such as the IEEE POSIX, then XOpen, and later the Open Group was formed to sort of bring that all together when the different vendors realized the benefits of bringing the innovation sort of to become a common platform. It's about building a standard platform on which you can innovate. So over time, the standards have actually added more and more sort of common interfaces, and therefore raising the bar upon which you can place that innovation. So over time, we've seen sort of like in the mid-90s, I remember there was a shift from 32-bit to 64-bit computing. At that time, it was like, how will we do that? Will we do it the same way? So all the Unix vendors came to what was XOpen at that time. We had an initiative called the Large File Summit, and we agreed the common way to do that. And so, that was a very smooth transition. So, today everybody takes it for granted that, the Unix systems are scalable, powerful, reliable. This is all built on that, the 64-bit platform and multiprocessor and all these sort of capabilities. So that's where we've seen the standards really come in, allowing the philosophy, the sort of enduring, adaptable sort of base that is the platform, the Unix platform, to be relevant today. So, we're seeing it's, today's virtualization, cloud, big data. It's all sort of driven by Unix systems in the back office.
So while we're looking at UNIX 45-year history, we're focusing the 20-year anniversary on the single UNIX specification and the ability to certify against that, and that's what the Open Group has been involved in, right?
Yeah. We were sort of given the Unix trademark from Novell back in, I think it was 1993, and at that point, the major vendors came together to agree on a common specification. At the time, the code name was Spec 1170, because there were actually 1,168 interfaces in the spec, but we wanted to round up. And apparently, that was also the amount of money that they spent at the dinner after they completed the spec. So we brought that specification out, and we've been running certification programs against that.
Well, Darren, let's go to you on a similar note. What is it about the dynamic nature of our industry now with cloud and hybrid cloud and mobile and a tightening between development and operations? How is it that UNIX is relevant today, given these things that no one really saw coming 20 years ago?
Yeah, no, that's a really great question. I think I can speak for everybody here that all our companies provide cloud services, whether it's public cloud, private cloud, hybrid cloud, and whether it's infrastructure as a service, software as a service, or any of the other as a service options. And the interesting thing is that to really be able to provide that consistency, that capability to our customers, we rely on a foundation, and that foundation is UNIX. So our customers, even though they can, maybe start with IBM, they have choice. And in turn, it actually, from a company perspective, it allows us to, instead of having to reinvent the wheel all the time for the customer or for our own internal development, allows us to really focus on the value add, the services, the capabilities that build upon that foundation of UNIX. So something that may be 20 years old, or actually 40 years from the original version of UNIX, has evolved with such a solid foundation that we can innovate.
And what's the common thread around that relevance remaining? Is it the fact that it is consistently certified, that you have assurance that what's running in one place will run in another on any hardware? How is it that the common spec has been so instrumental in making this a powerful underpinning for so much modern technology?
Yeah, I think a solid foundation is built upon standards because we can have, like you mentioned, assurance. If you look at the certification process, there's more than 45,000 test cases that gives assurance to developers, to customers, that there's going to be determinism. And of anything, all the IT people that I've talked to, deterministic behavior is so critical because when it's non-deterministic, things go wrong. So having that assurance enables us to focus on what sits on top of it, rather than does the ls command work right, or can we know how much space is in a file system? Those are givens. We can focus on the innovation instead.
What's also interesting over the past decades is that UNIX has found itself at the highest echelon of high-performance computing in high-performance cloud environments, and then down to the desktop, as well as into mobile devices, pervasively, and micro devices, embedded and real-time compute. How has that also benefited from a standard? Is it that common that you will see a single code base or a consistent code base up and down the spectrum from micro to macro?
Yeah, so if you look at the standard, it actually contains several components. And it's really modular in a way that, depending on your need, you can pick a piece of it and support that. Maybe you don't need the complete operating system for a highly scalable environment. Maybe you just need like a microcontroller. Well, you can pick the standard, so there's consistency at that level. And then that feeds into, let's say, the development environment in which an engineer may be developing something on. And then that scales to, let's say, you need a lot of those services on a large data center where you've still got that consistency throughout. And whether it's Solaris, AIX, HPUX, or even FreeBSD or Linux, there's a consistency because of those elements of the standard.
Now, developers are, of course, essential in making any platform continue over time. The chicken and the egg relationship. The more apps, the more relevant the platform. The stronger and more pervasive the platform, the more likely the apps. So, Jeff, for developers, what are some of the primary benefits of UNIX, and how has that contributed to its longevity?
Well, I think, as was said, for developers, it's the consistency that really matters. UNIX standards develop and deliver consistency. So as we look at this, we talk about consistent APIs, consistent command line, and consistent integration between users and applications. This allows the developers to focus a lot more on interesting challenges and customer value at the application and user level. They don't have to focus so much on interoperability issues between OSs, or even interoperability issues between versions of the single OS. Developers can easily support multiple architectures and heterogeneous environments. And in today's virtualized, cloud-ready world, that's critical.
And while we talk about the storied past with Unix, there's a lot of runway to the future. Developers now looking at issues around mobile development, cloud-first development. How is Unix playing a role there?
The development that's coming out of all of our organizations and more organizations is focused first on cloud, and it's focused first on a fully virtualized environment. And then it's not just the interoperability with applications, but it is the interoperability between, as I said before, the heterogeneous environments, the multiple architectures. In the end, customers are still trying to do the same things that they always had. They're trying to use applications and technology to get data from one place to another and more effectively, efficiently use that data to make business decisions. That's happening more and more mobilely, right? I think every HPUX, AIX, Solaris, Unix system out there is fully connected to a mobile world and the Internet of Things. We're actually securing it more than many customers realize.
All right, Tom, let's talk a little bit about the hardware side and the ability to recognize that cost and risk have a huge part of decision-making for customers, for enterprises.
Yeah.
What is it about Unix now and into the future that allows a hardware approach that keeps those costs down and those risks down, that makes that a powerful combination for a platform?
Right. I mean, through the standards and just the Unix environment, right? I mean, the key values that are being delivered there are really around, you know, you were kind of talking about the hardware. It, you know, traditionally has been a scale-up environment. You know, there's a lot of virtues and customer values around scale-up. It's a much more simpler environment to be able to administer versus the scale-out environment that's going to have a lot more components and complexity. Right, so that's a big value. The other core value that is important to many of our customers is there's been a very strong focus on you know, reliability and availability and scalability. At the end of the day, you know, those three words are very important to our customers. I know that they're important to the people that run our systems because having those values allows them to sleep right at night and have weekends with their families and so forth. In addition to just running the business, things have to stay up, and it's been that way for a long time, 7 by 24 by 365. So you know, these three elements, reliability and availability and scalability, they've been a big focus, and a lot of that has been delivered through the hardware environment, in addition to the standards. The other thing that is critical is, and this is really a very important area where the standards figure in, is around investment protection. Right? Our customers, you know, they make investments in middleware and applications, and you know, they make those investments. They can't afford to go and regen those investments, you know, continuously as they move through generations of operating systems and so forth, right? And you know, the standards play in that significantly, right? They provide, you know, the stable environment. You know, there's, I think in the standards test suite right now, there's like 45,000 tests in there for testing for standards. So stable, you know, reliability, availability, serviceability, and this investment protection. So.
Now, we've looked at Unix through the lens of developers, hardware and performance and risk. But another thing that people might not appreciate is the close relationship between Unix and the advancement of the Internet and the World Wide Web. And that the very first web servers were primarily Unix.
Right.
It was the de facto standard. And then service providers, those folks hosting websites or hosting the Internet itself, were using Unix for performance and reliability reasons. So Darren, tell us a little bit about the network side of this. Why Unix has been so prevalent along the way when high-performance network and then the very important performance characteristics of a web environment came to bear.
Yeah, absolutely. And again, it's about the interconnectedness. I mean, back in in my younger years, I mean, having to interface Ethernet with Apple Talk, with pick your various technologies, you just the interfacing took so much time and effort. But what any standard, whether it's Ethernet standard or Unix, it helps bring things together in a way that you don't have to think about how to get data from one point to another. And you know, mobility really is about moving data from one place to another in a quick fashion where you can do transactions in microseconds or milliseconds or seconds. And you want some assurance that the data that you send from one place to another. But it's also about making sure, and this is a topic that's really important today, is security. Knowing that when you have data going from one point to another point, it's secure, and on each node or each point, security continues. And so standards and making sure that IBM interacts with Oracle, interacts with HPE, really assures our customers and the people that don't even see the transactions going on that they can have some level of confidence that they're going to have reliable, high performance, and secure networking.
All right, let's dig a little bit into this notion of standardization, certification, putting things through its paces. I suppose for some folks, they might be impatient with going through that they want to just get out there with the technology and use it. But a level of discipline and making sure that things work well can bear great fruit for those who are willing to go through that process. So Andrew, tell us a little bit about the standard process and how that's changed over the past 20 years, perhaps to not only continue that legacy of interoperability, but perhaps also increase the speed and the usability of the standards process itself.
Yeah, that's a good point. We've actually made quite a few changes since, in the way we're actually doing the standards development ourselves in that 20 years. It used to be that a group of us would meet sort of behind closed doors, in different locations, and there would probably be 3 of such groups. So there was an IEEE group would meet in one location, and then the next open, and an open group, and then an international standards group. And often they were the same people who had to keep going to these same meetings and seeing the same people, but wearing different hats. And so, and as I say, that was very much behind closed doors. Well, as that got towards the end of the 90s, people were starting to say, we were spending too much money, doing the same thing, and basically producing a pile of standards that were very similar but different. And so in late 1997, 98, we formed something that we called the Austin Group. And actually it was basically the open group's members, so it was Sun and IBM and HP, came to the open group at the time and said, look, we've got to go and talk to IEEE, and we've got to talk to ISO about bringing all the experts together in a single place to do the standard. So starting in 1998, we met in Austin at the IBM facility, hence the name the Austin Group, and we started on that road. So now today, since then, we developed a single set of books, and then on the front cover we stamp the designation of it being an IEEE standard, an open group standard, and an international standard. So the technical folks, they only have to go to a single place, do the work once, and then we put it through the adoption processes of the individual organizations. The other thing we've done since then, and so as we got into the new millennium, we've sort of changed our way as well. We don't actually physically go and meet anywhere anymore. We do everything virtually. And we've adopted some of the approaches of open source. You can go out to our bug tracker that's out there. Anybody can go in the bug tracker, file a bug against the standard, and see all the comments that go in. So we've opened that up everywhere, so we're completely transparent. With the Austin Group, we allow anybody to participate. So you don't have to be a member of IEEE or an international delegate anymore to attend. So we've had a lot of input and continue to have a lot of input from the open source community. So we've had prominent members of, Linux and open source communities, such as the libc maintainer, people who do the commands. They would actually come to us because they want to get involved. They see the value in the standards. They want to come to a common agreement about how the shell should work, how this utility should work, how they can port, threads and things into their environments, how they can find those edge cases, And also, we've also had innovation from Linux coming into the standard. So in the mid-2000s, we started to look at and say, well, what APIs have we got in Unix, but that are in Linux that we should have also in Unix. So we, in the mid-2000s, we actually added, I think there were like 4 specifications that we developed based on Linux interfaces from the GNU project that we've added in there. So in the areas of internationalization and sort of common APIs, that's one thing we've always wanted to do, is to look at raising that bar of common functionality. So Linux and open source systems, they very much are working with the standard as much as anybody else.
So something I'd like to add about the process and the mechanics, because in my organization I own it, and I think there's a couple of key points. One is it's great that we have an organization, open group, that not only helps create the standard or manage the standard, but is also developing the test suites for certification. So it's one organization working with the community, Austin Group, and of course IEEE and the open group members, to create a test suite that allows us to, again, we've mentioned 45,000 tests, right? If any one of our organizations had to create or manage that separately, that's a huge expense. They do that for them. That's part of the service. And they've evolved that, and it's grown. I don't know what it originally was, but I mean, 45,000 tests has grown, and they've made it more efficient in terms of the process. And it's a collaborative process. We have issues. Well, is it our issue? Is it the test suite issue? And there's great responsiveness. So, I mean, kudos to the open group, because they kind of make it easy for us to certify. It's really our obligation to get into that discipline. But if we factored into the typical QA process as we release the operating system, whether it's an update or a patch or whatever, then you know what, it just becomes pretty obvious. Next major release that you want to certify, well, you've done most of the heavy lifting. And again, the open group makes it really easy to do that.
So I think another element that's important on this cost point is just, back to the standards, the cost of doing development. The cost of doing that. I mean, imagine a world, particularly being an ISV, a software ISV, imagine a world where there were no standards, and that world existed at one point in time, right? And what that causes is, an ISV develops something, then they have to, report it, usually very significant development efforts to each platform. Right now, an ISV can come in because the interfaces and the capabilities on all of those systems will be different. See difference all the way across, right? Now with the standards, of course, ISV, right up to one platform, it's portable over to the other platform. So that's been crucial, right? I mean, is that the standards have actually encouraged innovation in the software industry, because it made it easier for developers to develop, right, and less costly for them to provide their stuff across the broad range of platforms. So that's been crucial. And we talk about we have 3 people from the major UNIX vendors on the panel, but there are other players there too. And the standards have been critical, over time for everybody, right? Particularly, when the Unix market was made up of a lot of vendors.
So as we understand the value of standards and we see the role that a neutral third party can play to keep those standards on track and moving rapidly, are there some lessons from Unix of the past 20 years that we can apply to some of the newer areas where standards are needed? And I'm thinking about cloud interoperability, hybrid clouds, so that you could run on premises and then have those applications seamlessly move to a public cloud environment and back. Andrew, starting with you, what is it about the Unix model and the open group certification and standardization model that we might apply to such efforts as OpenStack or Cloud Foundry or some other efforts to make a seamless environment for the hybrid cloud?
Well, yes, Dana. In our standards process, we're very much able to take on almost any problem, but this would certainly be a very exciting problem for us to look to tackle to bring parties together. But that's one thing we were able to do, is to bring different parties together, looking for that commonality to to try and build the consensus. That's the one thing we do. We get people in the room, people talk through the different points of view. What the open group's able to do is to almost provide a safe harbor where the different vendors can come in and not be seen as talking in a anti-competitive position, but actually frankly discussing the differences in their implementations and deciding for what's the best common way to go forward with setting a standard.
Anyone else on the relationship between Unix and hybrid cloud in the next several years?
I can talk to it a little bit. I think that the real opportunity, and I hope people listening to this, and especially in the OpenStack community, kind of listens, is that I think that true innovation can be best done on a foundation. In OpenStack, it's a number of communities that are loosely affiliated, delivering great progress, but there's interoperability, there's issues and it's not with intent, it's just people are moving fast. If some foundation elements can be built, that's great for them, because then us as vendors can more easily support the solutions that these communities are bringing to us, and then we can deliver to our customers. So I think cloud computing, because it is, I'll call it the Wild West, right? We've got Azure, we've got OpenStack, we've got AWS, really could benefit from some consistency. Now, I know that each of our companies will go to great lengths to make sure that our customers don't see that inconsistency. So we bear the burden for that. But what if we could spend more time helping the communities be more successful rather than, as I mentioned before, reinventing the wheel? So I think there's a real opportunity to have that synergy.
Jeff?
Yeah, I think in hybrid cloud environments, what Unix brings to customers is security, reliability, and flexibility. So the Wild West comment, very, very true, but I think Unix can present that secure, reliable foundation to a hybrid cloud environment for customers.
Very good. Lastly, let's look at this not just from the lens of technology, but some of the more intangible human cultural issues like trust. It seems to me that at the end of the day, what makes something successful, as long as Unix has been successful, is that enough people from different ecosystems, from different vantage points, have enough trust in that process, in that technology, and through the mutual interdependency of the people in that ecosystem to keep it moving forward. So let's look at this from the issue of trust and why we think that that's going to enable a long history for Unix to come. And why don't we start with you, Andrew?
I think we like to think the Open Group is a trusted sort of party for for building standards. That we've got the that we look to hold the specification in trust for the industry and do the best thing for it. We're fully committed and always to continue working in that area. We provide a lot of we're basically the secretariat, and so we're sort of enabling our customers to sort of I think you were saying to save a lot of costs. Really, we're able to divide up the costs of if the Open Group does something once, that's much cheaper than everybody doing the same thing themselves. So if we can, like as you say in the cloud, if there's stuff that we could do together just once to reduce the glue that you're having to put in place to the plaster, the glue to make all these other solutions appear seamless to your customers, that would be.
Darren, do you agree with my premise that trust has been an important ingredient that has allowed Unix to be so successful, and how do we keep that going?
Yeah, and I think that the foundation of Unix, even going back to the original development, but certainly since standards came about, is the one word: open. You can have an open dialogue in which anybody's invited. In the case of the Austin Group, it's everybody. Actually, in the case of any of the efforts around Unix, it's an open process. It's open involvement, and in the case of the Open Group, again another open, it's vendor neutral. So their goal is to find a vendor neutral solution. And also look at it this way: I mean, we've got IBM, HP, Oracle sitting here, and I'll say virtually Linux, other communities that are participating, coming to a mutual agreement saying this is what we believe is best. And you know what? It's open to disagreement. We disagree all the time. But in the end, what we deliver and execute is a mutual agreement. So it's open, it's deterministic, and we all agree on it. So I think if I were a customer or IT professional or even a developer, I'd be going, hey, you know what? This foundation is something on which I want to innovate because I can trust that it'll be consistent. Open Group's not going away anytime soon. I mean, celebrating 20 years of supporting the standard, there's going to be another 20 years. And the great thing is that there's a lot of opportunity to innovate in computer science in general, but on the standard, building that foundation, taking advantage of topics like security, virtualization, mobility, the list goes on. We really have opportunity to, in an open way, build something that people can trust.
Tom, openness and trust, a good model for the next 20 years?
It is a good model. I mean, I think Darren touched on it. I mean, if we need proof of it, we got 20 years of proof of it, right? The Open Group has brought together major competitors, and as Darren said, it's always been very open, and people have always, even with disagreements, come to common consensus. Right? So the Open Group has been very effective at establishing that kind of environment, that kind of trust.
Well, great. I'm afraid we'll have to leave it there. I'd like to thank our panelists today for joining this discussion about the enabling innovation through UNIX on its 20th anniversary. Congratulations to the Open Group and to the UNIX community for that. And also look for more information on UNIX at the various sites on the Open Group. They have many landing pages for work that's progressing still. And thank you all for your attention and input.
Thanks,
Thank
Dan.
you very much.